The stars above me are closing in, so water rolls.
D-2 Inc. Oceanography News. Welcome to D-2 Oceanography and Marine Science News, and our first story of this episode is how increased hyperactivity of hurricane season is providing a wealth of research data. This image here was taken from inside Hurricane Milton by a new technology, a USV built by Saildrone. New technology brings forth new opportunities, and in 2021, NOAA and Saildrone launched a multi-year mission to deploy Saildrone Explorer uncrewed surface vehicles, USVs, into tropical storms and hurricanes to measure near-surface atmospheric and upper ocean data to better understand how ocean-atmosphere interaction affects hurricane intensity and how to improve hurricane prediction model. With 12 Saildrone Explorers stationed in 5 operational areas in the tropical Atlantic and Gulf of Mexico, NOAA and Saildrone had 3 intercepts with sustained hurricane force winds, the most ever. In Hurricane Ernesto, Hurricane Helene, Hurricane Milton, and 9 intercepts with at least 50-knot sustained winds. The 2024 hurricane season, predicted to be above normal, began with the earliest ever Category 5 hurricane in the Atlantic, Hurricane Beryl, in early July, and ended with Rafael, the westernmost major November hurricane on record. Saildrone sailed into both. Quote, "In a lot of ways, this was the most successful hurricane mission we've ever had," unquote, said Greg Foltz, an oceanographer at the National Oceanic and Atmospheric Administration, NOAA's Atlantic Oceanographic and Meteorological Laboratory, AOML, and one of the principal investigators on the mission. The threshold for hurricane force winds is 64 knots. The National Hurricane Center measures winds at height of 10 meters, 30 feet above the surface. Saildrone Explorers equipped for hurricane monitoring measure wind speed at 3.5 meters, 11 feet above the surface. Quote, "Wind speed decreases closer to the ocean surface. At 10 meters, wind speed can be 15% higher. So it's even more impressive that we are measuring sustained hurricane force winds so close to the surface," unquote, said Foltz. And another first, 2 Saildrone Explorers intercepted different parts of the eye wall of the same hurricane within a couple hours of each other. Quote, "We did that in Hurricane Ernesto, and then we did it again in Hurricane Helene. The big research question is, how does the ocean interact with the hurricane in different parts of the storm?" unquote, asked Foltz. The area in a hurricane with hurricane force winds is a relatively small target to hit. For hurricanes that originate in the eastern Atlantic and track west, the wind field is wider on the right side or northern side of the storm, where the storm, winds, and waves are all moving in the same direction. Quote, "We almost always go for the right side of the storm, which is where the winds are strongest, and it's a bigger target to shoot for. So we have a lot of data on the right side. Ocean waves and hurricane winds affects the exchanges of heat and momentum. On the left side, the winds are usually weaker, but the wind and waves are going in the opposite direction. And we really want to understand that better," unquote, said Foltz. In 2023, multiple Saildrone Explorers intercepted Hurricane Lee, but the intercepts were at least a day apart, so the structure of the storm had changed. This image, captured by Saildrone 1057, is Hurricane Debbie as it approached. The Saildrone Explorer intercepted 4 hurricanes in 2024, Debbie in August, Helene in September, Milton in October, and Rafael in November. This image here is an example of one of the Saildrones that is sailing into these hurricanes. All it's missing is a conductivity temperature depth sensor from D2 Incorporated, of course. Several of the season's intercepts, notably Hurricane Helene and Hurricane Milton, occurred in the Gulf of Mexico, where the ocean is much shallower, less than 100 meters, 300 feet deep. In a shallow area of the ocean, wave height can nearly match the ocean depth. The friction with the seafloor can have big impact on the waves break and the structure of the waves, which can in turn influence the winds in a hurricane. Quote, "The really badly understood and not understood in the models at all, the models predict hurricanes' intensity. I'm really looking forward to analyzing the data from the Gulf of Mexico and, in fact, using the photos and videos captured by sail drone to look at the roughness of the ocean and the drag effect on the winds, said Foltz. Those images are valuable not only for warning coastal communities about oncoming storm, but also for research, unquote. The mission was initially designed as purely research mission, but over time, constituents in other NOAA departments, including National Hurricane Center and National Weather Service, have integrated the real-time sail drone data into forecasting and advisories. The data is transmitted via satellite and fed into models every 6 hours to provide a better idea of the initial conditions, improving the forecast. Quote, we're still focused on the research, but it's been a happy surprise to see the value of the sail drone data for real-time forecasters, unquote, said Foltz. In total, sail drone USVs traveled over 27,000 nautical miles and gathered 768 total days of observations. Sail drone intercepted hurricanes 16 times and spent 102 hours in tropical storm force winds, providing near real-time data from above and below the sea surface. Sail drone measured a maximum of 3-second wind gusts of 99 knots, 114 miles per hour, and a maximum significant wave height of 13.5 meters, 44 feet. In the search for alien life, it was once again found again in the deep oceans of Earth. The newly discovered crustacean Dulcibella kemenchaka is the first large, active, predatory amphipod from the extreme depths of the Atacama Trench. Did you know that the deepest parts of the ocean are called the Hadal Zone, named after Hades, the Greek god of the underworld? This area is known for its crushing pressures and extreme darkness, but it's not completely void of life. In fact, WHO's Johanna Weston, along with researchers from Instituto Millennial de Oceanografía, recently discovered a new type of crustacean in the Atacama Trench near Chile. At 1.5 inches, the newly named Dulcibella kemenchaka is the largest known predator in the Hadal Zone. With raptor-like pincers and tusk-like front appendages, this fast-swimming amphipod is likely one of the most fearsome animals to make its home at 25,000 feet deep. As exploration technology advances, scientists anticipate uncovering more species, each offering insights into the evolutionary pressures and adaptations unique to the deep ocean, which is in its own right an alien world of itself. The Dulcibella kemenchaka is a fast-swimming predator that we named after darkness in the languages of the peoples from the Andes region to signify the deep, dark ocean from where it predates. Study co-author and WHOI Hadal ecologist Johanna Weston said in a statement. You can see where the Dulcibella was found in the Atacama Trench, which is one of the deepest trenches in the entire world. Despite being cold, deep, dark, the Atacama Trench is located beneath some very nutrient-rich surface waters that allow some life to flourish. The trench is very far away from other hadal environments, so it's home to a very distinctive community of native species not seen in other parts of the world. Quote, most excitingly, the DNA and morphology data pointed to this species being a new genus too, emphasizing the Atacama Trench as an endemic hotspot, unquote, said Weston. During 2023 Integrated Deep Ocean Observing System, IDOOS, expedition aboard the RV Abate Molina, the team collected 4 Dulcibella kemenchaka at a depth of 25,925 feet. To collect the crustaceans, the team used a lander vehicle. This untethered platform is used for carrying various scientific equipment, including baited traps. The lander vehicle was moved to and from the ocean floor and carefully brought back to the ship's deck. The team found that the amphipods were frozen and the species underwent detailed morphological and genetic analysis at the Universidad de Concepcion. The study's collaborative effort and integrative approach confirmed Dulcibella kemenchaka as a new species and highlights ongoing biodiversity discoveries in the Atacama Trench. Study co-author and IMO oceanographer Carolina Gonzalez said in a statement, this finding underlines the importance of continued deep ocean exploration, particularly in Chile's front yard. More discoveries are expected as we continue to study the Atacama Trench. Scientists like Gonzalez and Weston believe that as exploration technology continues to advance, more species like this living in extreme environments will be uncovered. The findings from this research will add to larger efforts to better understand deep ocean ecosystems so they can be protected from climate change and pollution. The next story is what y'all came here for: sharks turning red. During a research expedition off of American Samoa last summer, these ocean white-tip sharks came over to check out Mesobot as the vehicle made its way to the mid-ocean twilight zone. Many deep-sea animals, including sharks, cannot see red light wavelengths, so red lights are used to gather imagery without disturbing them. Normally, we keep the lights off for eDNA sampling because we want a representative sample of the biodiversity, and the lights may disrupt that, as many animals may be attracted to light, said Annette Govindarajan, PhD, a Hui biologist and science lead for the cruise. But one way in which we combine the video and eDNA is through light baiting, intentionally leaving lights on and sampling to see if we can collect additional types of biodiversity so we can explore more of what's out there. This research was funded by Ocean Exploration Cooperative Institute, OECI, and included scientists from Hui, the Ocean Exploration Trust, University of Rhode Island, Lehigh University, and University of New Hampshire, in collaboration with the National Marine Sanctuary of American Samoa. Thousands of previously unknown mountains and hills spotted in Best Yet Seafloor map. Data from the SWOT satellite could stimulate studies of plate tectonics. The abyssal hills are the most common feature on the ocean floor, but they are also the hardest to see. Rarely rising more than a few hundred meters above the abyssal plain, these gently undulating hills line up to form sets of parallel ridges. They have been glimpsed in the fraction of the ocean that has been mapped with sonar but unseen elsewhere. Now, researchers have discovered more than 200,000 of these hills in the most detailed global map of the seafloor yet, created with radar data from the Surface Water and Ocean Topography SWOT satellite. Developed by NASA and CNES, France's National Space Agency, and launched 2 years ago, the 1.2 billion satellite measures ocean height within a few centimeters by looking for subtle way water piles up above seafloor features, tugged by their gravity. SWOT has revealed not just hills, but thousands of loftier seamounts and other features. The map could aid in studies of plate tectonics and ocean currents and help submariners avoid hazards. It's just amazing, says Yao Yu, a marine geophysicist at Scripps Institute of Oceanography who led the work. Published today in Science and presented this week at a meeting of the American Geophysical Union. Only 25% of the seafloor has been charted with sonar, the gold standard for mapping, and although there is a push to increase coverage with seafaring drones and autonomous submersibles, there is a whole lot of ocean left to go, says Larry Mayer, director of the University of New Hampshire's Center for Coastal and Ocean Mapping. The United States, for example, only finished mapping its own continental shelf last year. So the SWOT data fill a major need, Mayer says. This is a huge leap, he says. The scale of things you can see is fantastic. As you can see from the image made from the data here, it is quite detailed, and you can make out quite a large number of features on the sea floor from this data. Unlike traditional altimeters, which emit radar pulses and measure the returning reflections with a sensor on the satellite's body, SWOT catches reflections and antennas at the ends of 2-meter-long booms. Their size and separation result in more precise measurements. Although some doubted whether the booms could be aligned well enough to overcome errors, the spacecraft has performed flawlessly since launch, says Li Lung Fu, SWOT's project scientist at NASA's Jet Propulsion Laboratory. There will be breakthrough results for years to come, he says. SWOT's main purpose is not to chart the ocean floor, but rather to measure flows of water in rivers on land and eddies. In the ocean, the giant chaotic swirls that drive much mixing in the sea, but among the large sea surface swellings and depressions they generate are smaller undulations reflecting previously unseen seafloor features. This last year, using existing altimeter satellites, you and others mapped larger seafloor features called seamounts, nearly doubling the known number ones to more than 40,000. Now the SWOT data should double that count again by finding seamounts as small as 450 meters in height and 4 kilometers in diameter. Beyond the hazard they present to submarines, one reason the U.S. military funds this work, such seamounts have been shown to shoulder deep ocean flows back to the surface, a critical mechanism in the conveyor belt of ocean currents that transport heat, nutrients, and carbon dioxide. Yu also hopes the SWOT data will shed light on how seamounts can create small swirling vortexes that mix surface waters and this year trap the world's largest iceberg. The SWOT map also reveals undersea topography that reflects the large-scale forces of plate tectonics in remote and largely unmapped polar regions. In shallow waters between the Canadian Arctic islands, it captures a distinctive alternating hill and valley pattern caused by ancient rifting. In the Weddell Sea off Antarctica, the map displays the herringbone structure of a three-plate junction between South America, Africa, and Antarctica. It will pinpoint places where the real anomalies and strange things are, Mayer says. Most promising for studies of plate tectonics will be the abyssal hills, which the map now shows covers some 70% of the ocean floor. Formed by magma erupting along mid-ocean ridges where plates move apart and fresh ocean crust is formed, they typically form orderly parallel lines marching away from the ridges, the most distant ones being the oldest and most eroded. But the new map shows that in certain places, such as the southwest Indian Ocean, the lines abruptly change direction, information that can be used to improve reconstructions of plate history. The size and frequency of the hills can also capture how magma eruption rates changed over thousands of years as ice sheets formed and melted, altering sea level and hence the pressure on the ocean floor. Although plate tectonics is well understood, Yu hopes the global look at the fabric of the abyssal hills will revitalize the field. I'm optimistic to see another boom of theory development, she says. The global map will get better still. You and others are now training artificial intelligence models on both the sonar and satellite data where they overlap, then using what the models learn from the comparisons to improve the resolution of the SWOT-only readings. As is often the case with AI, they don't know why the model knows what it knows, Yu says, but it's already better than past maps. What do you do if you're out for your Christmas morning walk and you see a bunch of dolphins in your bay? Portsmouth, New Hampshire. Experts are trying to figure out why 5 dolphins got caught in the Piscataqua River this week. Seacoast Science Center was contacted about the dolphins Tuesday morning, and officials said this is the first time in the organization's history that there has been a mass stranding of marine wildlife in New Hampshire. Mother Nature this time around was working on our side, said Ashley Stokes, Director of Marine Mammal Conservation at the Seacoast Science Center. Center was called at about 8 a.m. on Tuesday about 5 stranded dolphins in the river. The call came from a Portsmouth Naval Shipyard observer whose job it is to monitor for marine wildlife while work is being done in the water. So the tide was actually incoming, which if the tide had been going out, would have been a whole different problem, Stokes said. After about 2 hours, all of the Atlantic white-sided dolphins were able to refloat themselves and swim free. The reasons why are still a mystery. Could be that there was bait running through, that they just happened to come up into the river, Stokes said. There have been other close encounters this year with marine mammals. In July, a breaching whale in Portsmouth Harbor capsized a boat. Quote, "There's always going to be a reason to it," said Michael Moore of the Woods Hole Oceanographic Institution. "We may or may not understand it, but it may be a natural thing," unquote. Experts said there are a number of reasons why more mammals are ending up in the river. Quote, "It may be a climate change driven thing," unquote, Moore said. "Maybe just the randomness where food is and where it isn't, or what is going on outside of the river system that brings the animals into the general proximity," unquote. "Anyone who sees marine life in an unusual space should leave the rescuing to experts." Quote, "Don't disturb them," unquote, Moore said. Quote, "Leave them alone." Stokes said there have been more reported sightings of dolphins. She said anyone who's worried about a marine mammal they have spotted can call the Marine Mammal Rescue Hotline at 603-997-9448 and take a photo if possible. Probing carbon remineralization in the deep ocean. Using a suite of autonomous gliders, researchers have gained a deeper understanding of a critical ocean process. The impacts of climate change would be far greater if not for the ocean. Through the biological carbon pump, the natural process of organic matter sinking and being remineralized into CO2, the ocean draws CO2 out of the atmosphere and into its depths. This critical part of the ocean's carbon cycle helps to slow the impacts of climate change. The amount of organic carbon stored in the ocean is mostly determined by the depth at which the remineralization occurs. Yet we lack a complete understanding of how or why this depth varies over time, as conventional methods to measure it are incapable of capturing the variability. In the Go-Kart project, which was funded by the European Research Council, a team of researchers led by Stephanie Henson, a principal scientist in the Ocean Biogeosciences Group at the National Oceanography Center in the United Kingdom, used autonomous underwater vehicles, AUVs, to measure remineralization depths in the ocean. We found that the variation in remineralization depth is happening on many different temporal scales, from daily to weekly and over seasons, explains Henson, Go-Kart project coordinator. The project also revealed how patterns of variability differ between regions. Through missions at Southern Ocean, a subtropical upwelling zone in the North Atlantic, all had different phytoplankton bloom dynamics, carbon fluxes, and remineralization depth, add Henson. Trials with autonomous gliders. Before embarking on their global quest, the Go-Kart team worked closely with the engineers at the National Oceanography Center in the UK to make sure the glider missions met their requirements. This included integrating new sensors, planning for longer deployment times than previously completed, and developing higher resolution sampling. Through various missions, the researchers uncovered unexpectedly higher temporal variability in the pump efficiency at sub-daily to weekly timescales, including a lot of episodic pulses of organic carbon flux. This kind of detailed data was only possible because we used underwater gliders. Ship-based measurements simply can't obtain the resolution or long time scales necessary to reveal this variability, notes Henson. The variability gives us a window in what drives biological carbon pump efficiency, as we can identify factors that vary on similar timescales. The team could use then the results to assess the current understanding of drivers of biological carbon pump efficiency and temporal variability, and identify knowledge gaps that might be addressed with future autonomous or shipboard missions or in future model development efforts. I'm really proud of the fantastic scientific results we delivered, of course, but I think I'm most proud of the people who came together to form the Go-Kart team, says Henson. We established a group at the leading edge of using AUVs for marine biogeochemistry that is recognized internationally for its excellence and innovation. The Go-Kart team will continue to study the biological carbon pump using gliders and other technologies. The research is now using not only gliders but also autonomous floats and unmanned submersibles, while undertaking missions throughout the ocean to explore if the Go-Kart results are valid elsewhere. Henson concludes, as with many projects, we increased our understanding of some aspects of the pump, but now have a whole raft of new questions. Hungry yet? Because those are some beautiful potato rocks. From Tech Demystified on Twitter, deep sea batteries powering the future or disrupting the ocean. Imagine rocks on the ocean floor acting like giant batteries, churning out oxygen. Sounds like science fiction, right? Well, that's exactly what researchers have discovered lurking in the deep trenches of the Pacific Ocean. The power of the potato-shaped rocks. Scientists have stumbled upon strange potato-shaped rock formations that seem to be natural batteries. These geobatteries are packed with metals like manganese and nickel, key ingredients in regular batteries. Here's the twist. These rocks appear to be using these metals to generate electricity, and a byproduct of that electricity, oxygen. This discovery rewrites our understanding of how oxygen reaches the deepest parts of the ocean where sunlight can't penetrate. These deep-sea batteries could be a crucial part of the ocean's ecosystem, providing a much-needed oxygen boost to creatures living in the abyss. What's the catch? The area where these geobatteries were found is also rich in resources coveted by the deep-sea mining industry. Experts worry that mining these resources could disrupt these natural batteries, potentially suffocating the deep-sea ecosystem. The discovery raises a critical question. How do we balance technological advancements with the need to protect our oceans? Can we develop sustainable deep-sea mining practices that coexist with these natural wonders? The red tide offshore Southern California brings a spectacular display of bioluminescence to beaches at night. From glowing waves seen at several San Diego beaches to swirls of electric blue light stirred by dolphins gliding through the water off Newport Beach, photos and videos of this phenomenon are making the rounds on social media. But what is the science behind this natural light show? Bioluminescence expert Michael Latz, a scientist at Scripps Institution of Oceanography at UC San Diego, said the red tide is due to aggregations of dinoflagellate Lingulodinium polyedra, a species well known for its bioluminescent displays. Each microscopic cell contains some sunscreen, giving it a reddish-brown color. On sunny days, the organisms swim toward the surface where they concentrate, resulting in the intensified coloration of the water and the reason for the term red tide. At night, when the phytoplankton are agitated by waves or other movement in the water, they emit a dazzling neon blue glow. Red tides are unpredictable and not all of them produce bioluminescence. There is no red tide monitoring program, but the Southern California Coastal Ocean Observing System, SCCOOS, at Scripps Oceanography performs weekly sampling for potential harmful algal toxins. The Scripps Shore Stations program also collects daily water samples and performs plankton analysis twice a week. Ladd said that local red tides of L. polyedra have been known since the early 1900s due to observations by Scripps scientists. There are several Scripps scientists sampling the current red tide to learn more about the genetic and metabolic characteristics of the organisms. Scientists do not know how long the current red tide will last, as previous events have lasted anywhere from 1 week to a month or more. Bioluminescent displays are viewed best from a dark beach at least 2 hours after sunset, though visibility is not guaranteed. Anyone visiting the beach should make sure the beach is open according to guidelines set by your local city and maintain social distancing. For up-to-date information on visiting San Diego beaches, visit this website linked here. Another alien lifeform discovered, once again on Earth. MBARI researchers discover a new lifeform deep in the sea. Described a remarkable new species of nudibranch from the depths of the Midnight Zone, nicknamed the mystery mollusk. Bathydevis caudactylus swims with a fingered tail, uses a cavernous hood to capture food, and glows with a brilliant bioluminescence. Thanks to MBARI's advanced underwater technology, we're able to prepare the most comprehensive description of a deep-sea animal ever made. We've invested more than 20 years in understanding the natural history of this fascinating species of nudibranch. Our discovery is a new piece of the puzzle that can help better understand the largest habitat on Earth, said MBARI senior scientist Bruce Robison, who led efforts to describe the mystery mollusk. MBARI researchers first observed the mystery mollusk in February 2000 during a dive with the Institute's remotely operated vehicle, Tiburon, offshore of Monterey Bay at 2,600 meters. The team leveraged MBARI's advanced and innovative underwater technology to gather extensive natural history information about the mystery mollusk. After reviewing more than 150 sightings from MBARI ROVs over the past 20 years, they published a detailed description of this animal. After gently collecting a specimen, MBARI researchers were able to take a closer look at the animal in the lab. Through detailed investigations of anatomy and genetics, they began to solve the mystery, finally confirming that this incredible animal is a nudibranch. Most nudibranches, also known as sea slugs, live on the seafloor. Nudibranches are common in coastal environments, including tide pools, kelp forests, and coral reefs, and a small number of species are known to live on the abyssal sea floor. A few are pelagic and live in open waters near the surface. This mystery mollusk is the first nudibranch known to live in the deep water column. This species lives in the ocean's midnight zone, an expansive environment of open water, 1,000 to 4,000 meters below the surface, also known as the bathypelagic zone. In the category of more bad news for people who love to ski, therefore need snow, declining Antarctic sea ice cover is generating unprecedented ocean heat loss to atmosphere and more storms, according to a new study led by UK's National Oceanography Centre. The study published in the journal Nature focused on the record low Antarctic winter sea ice cover in 2023 and provides the first clear picture of the impacts of the disappearing sea ice. Using data from the atmospheric layer just above the ocean surface, it found the doubling of heat loss to the atmosphere, matched by the higher numbers of storms around much higher latitude Southern Ocean. The study also warns of potentially far reaching impacts on the deeper ocean circulation due to the heat loss making Antarctic surface waters denser than previously seen. Lead author Professor Simon Josie says the results point to an urgent need to use state-of-the-art ocean and climate simulations, such as those currently undertaken by NOC, to better understand the broader impacts of Antarctic sea ice loss, which could ultimately extend to the northern hemisphere. It's too early to state whether 2023 and its record-breaking sea ice decline marks the onset of a fundamental shift in the amount of Antarctic sea ice, says Professor Josie, an expert on ocean-atmospheric interaction at NOC, which is a leader in ocean and climate research. However, our study does reveal the extreme conditions to be expected in future years of low ice regrowth, with 2024 looking like it's continuing the sharp change seen in 2023. Based on our study, years of low sea ice, this will continue to have more storms and greater changes to ocean properties that could impact wider ocean circulation. Repeated low ice cover conditions in subsequent winters will strengthen these impacts and may result in profound changes further afield, including the tropics and northern hemisphere. Sea ice cover provides a winter blanket over the high latitude Southern Ocean, which stops it from cooling through exposure to the atmosphere. With the blanket removed, heat is lost into the atmosphere and surface waters become cooler and denser. You can see here this graph of how this heat loss system works and how it creates denser water near the surface. D-2 has participated in these kind of studies with the ITP program, and in the future will be called the TOP program, where you can put a D2 ink CTD on a ice profiler that goes down through the ice to measure the salinity of the ocean water, which from that you can derive the density. Sea ice cover around Antarctica hit a record low in 2023, with ice reductions in strong loss regions 50 to 80% below the 91 to 2020 winter average. Ocean heat loss to the atmosphere at some locations has more than doubled, and an increase in storms has been observed around much of the high latitude Southern Ocean by up to 7 days a month. Previous analysis of the long-term impacts of declining Antarctic sea ice by co-author Dr. Holly Ayres, formerly at University of Reading and now at NOC, shows that enhanced ocean heat loss can also affect the climate as far away as the tropics and the northern hemisphere. The study also found that disappearing sea ice is allowing the ocean surface waters to change their properties, particularly density, Professor Josie notes. The massive increase in ocean heat lost to atmosphere is increasing the density of water at the sea surface to values not previously seen in the newly ice-free regions. Co-author Dr. Andrew Meigers from the British Antarctic Survey explains further. The location of this new denser surface water is relatively far from the sites at the Antarctic shelf where the densest and deepest waters of the global ocean are formed. However, this cooling and subsequent sinking of waters previously covered by sea ice has the potential to release deeper, warm waters that would normally be kept away from ice by an insulating surface layer. In turn, this has potential for increasing sea ice melt in future years. Quote, further analysis is urgently needed to understand these processes and their complex feedbacks and determine how massive decline of winter sea ice in 2023 and again this year will impact the Southern Ocean circulation. This is key to understanding the climatically critical ocean uptake of the atmospheric heat and carbon and the rate of melt of the Antarctic continent. We now need a more detailed understanding of the strengthening ocean heat loss in the regions of declining Antarctic sea ice and its wider impacts, adds Professor Josie. This is vital to understand how the increased number of storms are linked to the extra heat supply into the atmosphere, and for determining long-term societal risks, including potential changes to weather conditions in the decades ahead in locations far removed from Antarctica. Critically, we need to use our ocean and climate simulations to understand how the major increase in heat loss and increased surface water density impacts the wider ocean circulation. Thank you for watching D2 Inc. Oceanography and Marine Science News, Episode 2.